Hello students, welcome to my YouTube channel and welcome to the topic of probability. So, probability is the topic of your 11th class mathematics book. So, let us start the topic probability from the definition of part. And here it is the definition. It is the measure of uncertainty of various phenomena. The word uncertainty means which is not certain. Then let us go through the topic probability briefly. We are going to discuss the topic probability, which comes from the word experiment. An operation which results with some well-defined outcomes is called as experiment. There must be some outcomes of a experiment and the outcomes must be well-defined. And again, this word experiment or the term experiment is divided into two types, or it is of two types. The first one is deterministic experiment and the second one is random experiment. Then let us go through what is deterministic experiment with some example and what is random experiment with some example. So here it is the first type of experiment, and that is deterministic experiment. In your day-to-day life, we perform many activities or experiment which have a fixed outcome or result. No matter any number of times they are repeated, such experiment is known as deterministic experiment. That means they have a fixed outcome, known outcomes, and they are known before the completion of the experiment. So like you may take any type of triangles, and before the completion of drawing the triangle or construction of a triangle, you can guess that the sum of the three angles present in the triangle will be equal to 180 degrees. So you can guess before the completion of experiment, and that type of experiment is called as deterministic experiment. Then let's move towards to the random experiment. So here it is the definition. You may write down the definition, and it is the definition of deterministic experiment. Before going to the exercise and some of the formulas, first of all you have to write down the definitions, so some of the concepts before the chapter. Then coming to the second type of experiment, that is called as random experiment, and an experiment whose outcomes cannot be predicted or determined in advance before the completion of the experiment is called as random experiment. That means the results or the outcomes of the experiment cannot be predicted or cannot be guessed before the completion of the experiment. That is called as random experiment. Such type of examples are tossing a coin, rolling a die. These are called as random experiment, because we cannot predict whether it will be head or it will be tail before the tossing of the coin. Similarly, we cannot predict the numbers from 1 to 6 before the complete experiment, that means the rolling of the die. So next, coming to the sample space of the topic probability. Then coming to the concept of a sample space, the set of all possible outcomes of a random experiment is called a sample space. The topic probability is totally based upon random experiment. That means we know that experiment is of two types. One is deterministic experiment and random experiment. Probability is based upon the second type of experiment, that is a random experiment, in which the result cannot be guessed, predicted or determined in advance. And probability is based upon that experiment, that is called as a random experiment. So the set of all possible outcomes, the all possible results of a random experiment is called as a sample space, but that must be in the set form. The set of, so it is denoted by S symbol, the letter S. When a coin is tossed, then the sample space is defined by, when a coin is tossed, there may be two possibilities. There is two possibilities, either head or tail. So the set of all possibilities mean you have to consider a head as well as a tail. So the set of head and tail, that means they are separated by a comma and enclosed by two curly brackets, and that must be in set form and named as the letter S, capital S, and this is called as the sample space of the coin is tossed. The experiment of the coin is tossed once, when a coin is tossed a single time, and that is the sample space of that experiment, and the cardinality of S is equal to 2. Example 2, when two coins are tossed simultaneously, or we can say that one coin is tossed twice, one after another, by tossing first time and then again tossing the second time. So when two coins are tossed simultaneously, either you have to take two coins and you have to toss twice, you have to toss once simultaneously, or you have to take a coin and you have to toss it twice, one after another. After the completion of first, you have to toss it again. And in that case, the sample space is denoted by head, 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 tail, tail, head, and tail, tail. And in this experiment, the cardinality of a sample space is equal to 4. Then coming back to some of the more examples based upon sample space. Then coming back to the example 3, 4 and 5, rest of the examples based upon sample space. If three coins are tossed together or a coin is tossed thrice, then the sample space is given by, you have already discussed it in your high school career. Then again, if a die is rolled once, then the sample space is given by, what are the total number of possibilities? What are the possibilities? What are the outcomes? All possible outcomes. If you will roll a die, what are the total outcomes? All possibilities in your results. That is called as the sample space. And the all possible results can be expressed as 1. It may be 1, 2, 3, 4, 5 or 6. So this should be written and in between the two curly brackets, and they are all separated by using the commas, and that is called as the sample space of the experiment when a die is rolled once. Then coming back to the fifth example, if a die is rolled twice or two dice are rolled together simultaneously, then the sample space is given by S is equal to, it may be 1, 1, 1 from the first roll and 1 from the second roll, and it will be 1, 2, it may be 1, 3, it may be 1, 4, dot, 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 it may be 6, 6. 6 may be in the first roll, 6 may be again in the second roll. So total number of possibilities in this case, in which the experiment is of a die is rolled twice or two dice are rolled together, then the total number of possibilities will be 36. Then coming back to the point, then I am going to discuss about the sample point of the topic probability. Now let us discuss about the sample point or event point. Each element of the sample space is called a sample point or the event point. That means a random experiment is performed. There are some well-defined outcomes, and by taking that outcomes or those outcomes, we are constructing a sample space, and that is denoted by S. Each and every element present in the sample space is called as a sample point. Let us take an example. And the example is when a die is thrown, then all possibilities of the outcomes are, which are the outcomes? Well-defined outcomes. 1, it may be 1 in the result, it may be 2 in the result, it may be 3, it may be 4, it may be 5, as well as it may be 6 in the result. So all of the elements are the outcomes of the experiment, of the random experiment. And by taking the help of these outcomes, so we are constructing a set. They are enclosed by two curly brackets, and they are separated from each other by a comma, and that is denoted by S. So each and every element present in the sample space is called a sample point. 1 is a sample point, 2 is a sample point, 3 is a sample point, 4 is a, 5 is a, as well as 6 is also a sample point. So each and every element, 1 is different from 2, 2 is different from 3. So all of the sample points are different from each other, and each of the sample point is the element of the sample space. So what are the total number of sample points in a sample space? The cardinality of the sample space denotes us or represents us the total number of sample points or event points of an experiment or of a sample space. Then let us go through event. Then let us discuss about the event. A subset of the sample space is called as an event. The subset of a sample space is an event. Any type of a subsets. We know that a set is always subset of itself. Similarly, sample space is subset of itself. So sample space is also an event. Okay? Then let us go through an example. Tossing a coin twice. If we will toss a coin twice, then the sample space will be in this form: HH, HT, TH, TT. Suppose there are 4 events. The first event is taken as the letter A, capital A, and you have to find out such type of a sample points such that it must contain at least one head. It must contain at least one head means you may carry 2 heads also, or you may choose 2 heads. It has been restricted. You have to consider those sample points which contains at least one head. So you may consider more than one. So at least one head, here is a one head, here is a one head, and you may consider more than one head because it is considered as at least one. You may consider more than one. So head is also considered. Similarly, event B, at least one tail. One tail is here, one tail is here. You may consider more than one tail because it has been considered or it has been asked at least one tail. You may consider more than one. Similarly, event C and event D. But from these 4 events, you may take a note here. The event which contains at least one head is almost equal to at most one tail, because in the event of at least one head, there is no existence of tail. Similarly, in the event of D, at most one tail, there is no existence of TT. So from these 4 events, you may take a note that the event which contains at least one head is totally equal to the event containing at most one tail. Similarly, the second note is the event containing at least one tail is totally equal to at most one head. So these are the some of the basic concepts based upon event. Then let us go through the last part of this kind of video session, that is the total number of possible events of a given sample space. Then coming to the total number of events of a sample space, as like in the set topic. If a set contains n number of elements in it, then the total number of subsets is equal to 2 to the power n. Here also, in the sample space, if the sample space contains n number of sample points, then the total number of possible events is equal to 2 to the power n. In the set topic, there was the word set, and here it is sample space. In set, there was element, and here is a sample point. In the set topic, there was total number of subsets, but here in the sample space, in the topic probability, it is the total number of events. So there is a result same as 2 to the power n. Suppose take an example here. Let us consider a coin is tossed once. Then sample space is equal to head and tail. The cardinality of a sample space is equal to 2. The total number of possible events, the total number of all possible events is equal to 2 to the power 2, that is equal to 4. So all possible events in the given sample space is equal to 4. So in this particular video session, just we have discussed about the basic concept of a probability, starting from the experiment, deterministic experiment, then random experiment, then sample space, then sample point. In the end, we discussed about the total number of events of a sample space. In the next video session, just we are going to discuss about the types of event of the topic probability, or existence of types of events in the topic probability. Till then, thank you.